start by, if you could introduce yourself very quickly. So, Oguz, let's start with you for a quick introduction.
So I'm Oguz from Switzerland. We have two companies. One is Switzerland, another one is in Istanbul now. We offer end-to-end industrial solutions, IoT solutions, from the sensors to the SCADA integration for control rooms, and growing for oil and gas industry, and now industrial park projects with all the 600,000 companies together. We integrate our solutions in critical environments, I will say.
Okay, we'll come back to you in a minute and find out a bit more about your company. Gonzalo, let's go to you next to a quick introduction.
So just quick intro about myself. I'm Gonzalo García, founder of Hotta. And basically the technology that we design at Hotta is liquid cooling technology for servers. And the particular thing is that we're also able to transform all the heat that is released by the server into hot water. What's really unique about Hotta is like how we use our technology, right? So basically we've designed a modular data center solution that we can place wherever there is a heat consumption. So for instance, we can go to a hotel, place there our micro data center, and while it's working, the hotel will be consuming our waste heat.
Okay, thank you. Jorge.
Well, I'm Jorge. I'm head of flexibility and planning in ITE, which is our research center located here in Valencia, in the Parque Tecnológico of Paterna. And we cover many areas related to the energy sector, any field. For instance, biosensors, chemistry, electromobility, smart grids, hydrogen, batteries, and many others.
Okay, great. Maybe, Jorge, we'll stay with you just for a little bit, just to find out a bit more about the sort of work you do, the types of projects that you work on, because you're a kind of research institute.
Well, in our case, for instance, according to my department, we are more related to the services that we can provide to the grid. For instance, algorithms that we can develop in order to help other people to define behaviors and to solve some kind of congestions in the grid. We also provide some kind of solutions for energy communities, defining some kind of models for energy assets, and let's say quantify according to several KPIs, technical, socioeconomic, environmental ones, KPIs in order to provide, let's say, solutions for other people to take decisions.
Right. So who would you be working for? Who's a typical client?
Well, it depends. We cover many fields of projects. For instance, we have some kind of public fundings, but also private fundings. And depending on the area, we go to one kind of a funder or another one. So it depends. If we want to fund our research, we go to public fundings.
Okay.
And if we want to sell and to transfer, because this is one of the aim of our center, to transfer technology, we go through the private side.
Okay, so a mix of different clients.
Yeah.
Oguz, let's get back to you and just learn a bit more about the company that you work for, that you run. So you're developing end-to-end solutions. So you're developing the hardware, the software. You're providing in-life support as well, as I understand it. And
it's already providing to field engineering as installation calibration devices. We are working for different areas, as I told you. For example, oil and gas industry.
Yeah.
It's difficulty implement something in ATEX area, which is your first step can your last step, you know. Another topic from Assistant smart metering area, we have a very good partnership now with IoT Alliance that we can solve our problems for networking, for example. Yes. Yeah.
Okay.
Mm-hmm.
And you're based in Switzerland, but you also have people in Istanbul.
Yes, we have two companies. One is in Switzerland. We can organize everything for marketing, so headquarters. And for field engineering, software developers, we have team in Istanbul. And we can solve every problems from Istanbul to worldwide, I would say. We have some customers from Holland or the Netherlands, some from Germany. Now starting to go to Saudi Arabia. Some projects we have done with Saudi Arabia companies together, and we can do everything from Istanbul, much more easy because of cultural things, etc.
Right.
And everything we can organize and catch up from Switzerland to the world. So.
Okay, very good. Gonzalo, let's go back to you, find out a bit more about your company. It sounds like you have a really interesting business model. So you've got these distributed data centers where you have your customers for the data centers, and then you put them in typically a hotel, something like that, and then the hot water goes and used for swimming pools.
Yeah, that's right. So yeah, that's something interesting about our business model, because basically we have here like two completely opposite markets. On one side, we are solving a solution on, let's say, energy efficiency for data centers. So we are providing a more efficient solution on computing. But also on the other side, basically what we are producing, it's hot water, right? It's our, let's say, waste. Yeah. So the way that we are doing is we are finding a way to monetize that waste heat, so other end customers can actually remove their heating cost, or at least reduce their emissions associated to the production of that heat, and basically combine two different walls using the waste from one to solve the problem for the other one.
Okay, it's a really interesting model. You said it's more efficient for the data center customers. Can you give us some sense of how much cheaper it is, or how do you measure that efficiency?
So basically we have here three main points, right? If we think about the data center market itself, on one side we need to cover the cost of the installation itself of the land, right? We need a place where we are actually placing our data center. Second, there is a huge cost due to basically the cooling consumption.
Yeah.
That's a huge cost. And then the third part is that usually those data centers cannot reuse their heat. So basically, they're just throwing it away.
Yeah.
With our deployment model, basically we are removing the cost of land, because we are placing a small data center in the, let's say, heat consumer facility. Second, we are removing 95% of the cooling consumption. And third, we are also making money from the waste heat.
Right. And how do you get the customers from the other side, like the hotels? Because it must be strange. You go knock on the door of a hotel and say, I want to put a data center.
It is. But actually, as soon as you start having like success cases, it's becoming easier, right? And basically what end customers are looking are for solutions that reduce their heating cost. And also, right now, for instance, as we are working also with hotels, heated pools, corporations, they are also looking for ways to reduce their carbon emissions, right?
Yeah.
And basically, if you are using waste heat from another process, you can actually certify that your heating is not consuming at all.
Right, very interesting. Let's talk a bit more about energy. Maybe, Jorge, I'll bring you back in as well. So clearly the energy market, it's in a period of transition. We've got lots of changes, both from supply and new sources of supply, more renewable energy sources, but also in terms of demand, new sources of demand, like data centers. So how do you see the market changing, and how do you see IoT supporting that change or making it easier?
Well, I think that this is a really good point. I mean, let's say the electric grid, the electric networks, historically they were built in order to, let's say, to insert the energy from the generators and then to be consumed by the consumers. Nowadays, we have, for instance, in our facilities, we have PV systems, we have also windmills. So let's say that the different energy patterns are changing. So we need to, let's say, to facilitate the grid operator in order to do their work, because the better they do is when, for instance, we don't know exactly what's going on with the grid.
Yeah.
Let's for instance remind what happened the 28th of April here with this called the blackout. It was because the system operator wasn't able to provide, let's say, a good service to the grid. They didn't define exactly what's going on with different technologies, and that's why I think that we have to provide some kind of other solutions. One of them is flexibility, which is the ability of change our behavior in order to let's say, provide this kind of solutions for, I don't know, for rewards or something like that. And I think we have to change the market.
Yeah. I mean, Gonzalo, your solution, well, part of it is it helps solve that problem because you haven't got this hot water going to waste. So it's quite neat.
Yeah, Basically, we're also solving. We're actually changing the patterns, right? Because basically, what we're doing usually is removing gas consumption and then introducing electricity consumption. But on the other side, we are also helping on reducing the impact of having new data center infrastructure consuming less, and also we are really kind of like stable on predicting what's going to be our consumption. Data center can like previously know how's going to be the consumption. That can help the provider and the grid to actually plan better how they are providing us with the energy.
And how much flexibility do you have in terms of when you're using your data center? Can you optimize that depending on when energy is cheaper or?
Yeah, actually something that we do, and that's an automatic system that is already introduced,
Right.
is that we sometimes also use and leverage renewable sources. So for instance, solar panels, and we actually use more energy and kind of like power a little bit more our servers when there is an opportunity to actually consume directly from the PV.
And how do you measure the impact of all of this?
So you can actually easily measure the impact of all of this, having like a clear metering on the energy, the electricity that you are consuming, and a clear metering on the heat that you are providing.
Right.
It's kind of like an easy calculation of the impact. So basically, you are removing the same amount of heat produced by gas, and then you are just introducing the same amount of heat produced by nothing, right? Because the main source of the main use of that energy is not actually providing heat; it's providing computing power.
Okay, good. Let's move on to our next topic and talk a little bit about predictive maintenance. So maybe Oguz, I'll go to you and just talk about how your system involves predictive maintenance and how that's changing.
We are collecting now the data so from different use cases from the field directly. For example, pressure or temperature monitoring, or valve position, or corrosion, etc. And we have to collect the data and then push the data in our system first one, and then to SCADA from our customer. And in between, we have now integrating now with an AI tool that we can not get the data and help to customer to show the dashboards, etc. Now we can tell them with AI for predictive maintenance, So in future, if they have to change some things or replacement part from the machines or compressor or pipes, they will get alarm from us directly here. If you use the system like 5 years in future, you have to change this part, and you have to be careful for this part, etc.
Right.
Yeah.
And did you say you were using AI for that, or there's a plan in the future to use AI as part
This
of?
is actually integration phase from us.
Right.
We will use after next year then.
Okay.
We are just collecting the data because you need the data for AI tools, and we are now collecting the data for our AI tools, and then we will use for predictive maintenance in future, near future.
Okay, very good.
Actually, we've got a real use case of that predictive maintenance that we've realized over the time that we've been working with Hotta, and is that when we apply predictive maintenance, sometimes even when we cannot solve the problem remotely, because we apply kind of like some remote actions. So for instance, if you think about the usual problems when you have a heating failure in a hotel, you would call the repairman. The repairman will come. Then they will check how's the status of the production system. They will go for pieces, and then they will come back. We can just remove one part of this operation, because when we send the repairman, we already know what's happening in the system. So we can just send directly the repairman and save time and money.
And he'll go with the correct part because he knows what's wrong. Okay. And finally, Jorge, on the same question.
In our case, for instance, we have developed a digital twin for PV systems. We are able to provide, let's say, like a theoretical output of the inverter for the whole installation, and we can identify if it is not working well, not only because they are not providing the input that the output of that we think that they should provide, but also according to AI models, for instance, deep learning models, we can develop forecasting and to identify exactly with weather stations. And if we obtain, for instance, the gradients, we know exactly according to these forecasting models that have been already developed by our data. Also, with this digital twin, exactly not only if they are not working well, but which is the problem that they are facing. For instance, they don't know exactly if this is a shadow, if there is dust in the panels or something like that. We can identify exactly what's going on. So we are combining both the digital twin for the PV system, but also a forecasting solution.
So you've got this idea. So you can tell what's going wrong. You can tell the amount of energy it should be producing, how much it's actually producing, and if that's caused by shadow of trees or something, or if it's caused by
because the forecasting model has been trained with our real data that they also count with these problems.
Okay.
So with these three outputs, we can identify the problems.
Excellent, very interesting. Unfortunately, that's all that we've got time for. So I just want to thank my panel for very, very interesting, and for competing against the opera singer, who does seem to have eventually finished. But so thank you very much. Thank you.